Earth, our home planet, is a world unlike any other. The third planet from the Sun, Earth is the only place in the known universe confirmed to host life. With a radius of 3,959 miles, Earth is the fifth largest planet in our solar system, and it's the only one known for sure to have liquid water on its surface. The beginning of our universe was the Big Bang. It was too hot back then, but it slowly cooled down. Different particles started bumping into each other, eventually forming common elements. Our solar system was formed roughly 8.7 billion years after the Big Bang. All solar systems begin in the same way, from nebulous. Collapsing of dust and gas molecules within the nebulae causes the formation of planets and stars. The gravitational pull comes into action here and pulls the gas molecules and dust particles together. As these particles increase in size, the attraction between the molecules increases. This eventually forms a planet. However, the planet was still too hot to sustain life. Eventually, the planet began cooling down. The oceans are where the origin of life occurred. Slowly, evolution caused organisms to move onto land too. Over millions of years, the Earth has gone through many cycles of heating up and cooling down. This has resulted in mass extinctions and the wipeout of civilizations and organisms. However, planet Earth has managed to give birth to new organisms and help them evolve every single time. Where did life on Earth begin? Two possibilities are in volcanically active hydrothermal environments on land and at sea. Some microorganisms thrive in the scalding, highly acidic hot springs environments like those found today in Iceland, Norway, and Yellowstone National Park. The same goes for deep-sea hydrothermal vents. These chimney-like vents form where seawater comes into contact with magma on the ocean floor, resulting in streams of superheated plumes. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplaces of Earth's first life forms. Organic molecules may also have formed in certain types of clay minerals that could have offered favorable conditions for protection and preservation. This could have happened on Earth during its early history, or on comets and asteroids that later brought them to Earth in collisions. This would suggest that the same process could have seeded life on planets elsewhere in the universe. Sunlight provides the energy source at the surface, which drives photosynthesis. On the ocean floor, geothermal energy supplies the chemical nutrients that organisms need to live. Also crucial are the elements important to life. For us, these are carbon, hydrogen, oxygen, nitrogen, and phosphorus. But there are several scientific mysteries about how these elements wound up together on Earth. For example, scientists would not expect a planet that formed so close to the Sun to naturally incorporate carbon and nitrogen. These elements become solid only under very cold temperatures, such as exist in the outer solar system, not nearer to the Sun where Earth is. Also, carbon, like gold, is rare at the Earth's surface. That's because carbon chemically bonds more often with iron than rock. Gold also bonds more often with metal, so most of it ends up in the Earth's core. So, how did the small amounts found at the surface get there? Could a similar process also have unfolded on other planets? The last ingredient is water. Water now covers about 70% of Earth's surface, but how much sat on the surface 4 billion years ago? Like carbon and nitrogen, water is much more likely to become a part of solid objects that formed at a greater distance from the Sun. To explain its presence on Earth, one theory proposes that a class of meteorites called carbonaceous chondrites formed far enough from the Sun to have served as a water delivery system. Earth formed around 4.5 billion years ago, so what is the condition of Earth today? A new planetary report card confirms that humans are making little progress on confronting the climate crisis. Global warming impacts everyone's food and water security. Climate change is a direct cause of soil degradation, which limits the amount of carbon the Earth is able to contain. Some 500 million people today live in areas affected by erosion, while up to 30% of food is lost or wasted as a result. How bad will climate change be in 2050? Just 25 years from now. Rising temperatures are fueling environmental degradation, natural disasters, weather extremes, food and water insecurity, economic disruption, conflict, and terrorism. Sea levels are rising, the Arctic is melting, coral reefs are dying, oceans are acidifying, and forests are burning. Plus the inflation in prices due to the scarcity of resources. All these things will lead to uncomfortable living for most of the humans. Period starts to go back to the Stone Age for many. Many move out of the cities and go back to the forests, and yes, a great divide will happen. But the planet Earth will find a way to reset the Earth from climate change to a factory reset without the complex life on this planet. Even if the complex life survives these kind of episodes, the Sun ultimately will swallow the Earth in 1.3 billion years from now. But you don't have to wait for that long till the outer layers of the Sun to reaches the Earth. The planet will experience extreme heat long before the Sun finishes its transition to a red giant. As the Sun's dying process turns up the temperature, oceans will evaporate. Then the atmosphere eventually goes away, and then the tidal forces of the Sun's gravity will shred Earth. Some life may survive to this point, like the extremophiles that live near hydrothermal vents in the ocean floor, but not humans. So enjoy the human life, and thank that you are still alive to watch these kind of videos. For more videos, please like the video and share. Goodbye until next time.